Differential leveling. Differential leveling is the process of measuring vertical distances from a known elevation point to determine elevations of unknown points. A thorough knowledge of leveling principles and proper application of methods and equipment will prevent costly delays and generate the needed results and accuracy. The following materials and equipment are required for this fieldwork: an auto level or a dumpy level, a leveling rod, poles or markers, and a plumb bob.
The first objective is to acquire and develop the skills of determining the elevation of a point from a benchmark of known elevation by establishing a single setup. Second is to acquire and develop the skills of determining the elevation of a point from a benchmark of known elevation by establishing multiple setups using turning points. Third is to develop the skills in using leveling instruments.
For the Part A, Single Setup Differential Leveling. Consider this field as the site. The instructor assigns the location of 2 points marked as A and B, which are intervisible with the instrument set up placed between the points. Set up the instrument level on the suitable points, preferable about midpoint of the two designated stations A and B, by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of instrument man through tripod leg locks. Check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Take the backside reading of point A where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or thousandth of meter. The rodman transfers the leveling rod of station B and must hold it with plumb bob alongside to maintain verticality of the rod. Take the foresight reading of the leveling rod, and again, the reading must be done up to the accuracy of a millimeter or thousandth of meter.
After recording the observed values, compute for the differences of the readings to determine difference in elevation between benchmarks. Repeat these procedures for the second and third trial. Tabulate the data in Table 4.1, Single Setup Differential Leveling. Compute for the most probable value using the formula of summation of the difference in elevation over the number of trials.
For the Part B, Differential Leveling with turning points, first, we must consider this field as another location. Then, the instructor assigns the location of another 2 points marked as A and B. Then, add markers along the course between the two benchmarks to serve as stations and as well as the turning point for the leveling. Then, set up the instrument level on the suitable points, preferable about midpoint of the two designated station A and B by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of the instrument man through tripod legs locks. Check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Take the backside or BS reading of point A where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or thousandth of meter.
Rotate the telescope until the newly established point designated as turning point TP can be sighted. The rodman transfers the leveling rod and must hold it with plumb bob alongside to maintain verticality of the rod. Take the foresight FS reading of TP where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or a thousandth of meter. Transfer the instrument to another location along the route to BM2. where the first turning point is still visible in the telescope. Follow the same procedures until you reach the second benchmark. Tabulate the data in Table 4.2, Differential Leveling with Turning Points. In order to tabulate Table 4.2, it is needed to determine the height of instrument, HI, and elevations on every benchmarks, stations, and turning points. To get the HI of the first benchmark, or PM1, add its elevation 100 meters to its recorded backside, or BS. After that, subtract the foresight of the first turning point, TP1, to the HI of BM1 in order to get the elevation of TP1. Then, the elevation of TP1 can be added to its BS in order to get its HI. Then, the FS of station 3 can be subtracted to the HI of TP1 in order to get the elevation of station 3. Then, the elevation of station 3 can be added to its BS to get its HI. And the FS of the second benchmark, BM2, can be subtracted to the HI of station 3 in order to get the elevation of BM2. With this, the elevation of every stations are now determined.